CIA world. A year only lasts 17 and a half hours on the Hell planet. CIA. The exoplanet 55 Cancri E goes by several names, but the rocky world located 40 light years from Earth is most known for its reputation as a hell planet. This super-Earth, so named because it's a rocky planet 8 times as massive and twice as wide as Earth, is so scorching hot that it has a molten lava ocean for a surface that reaches 3,600 degrees Fahrenheit, 1,982 degrees Celsius. The exoplanet's interior might also be full of diamonds. The planet is hot enough that it has been compared to the Star Wars lava world of Mustafar, site of the battle between Anakin Skywalker and Obi-Wan Kenobi in Revenge of the Sith, where Darth Vader later establishes his castle, Fortress Vader. The planet formerly named Jansen, also referred to as 55 Cancri E or 55 CNCE, orbits its host star Copernicus so closely that the sizzling world completes one orbit in less than one Earth day. 1 year for this planet lasts about 17 and a half hours on Earth. The incredibly tight orbit is why Jansen has such intensely hot temperatures, so close that astronomers doubted a planet could exist while practically hugging a host star. Astronomers wondered if the planet had always been so close to its star. A team of researchers used a new tool known as Express, or the Extreme Precision Spectrometer, to determine the precise nature of the planet's orbit. The findings can help astronomers gain new insight into planet formation and how these celestial bodies evolve in orbit. Evolving orbit. The instrument was developed at Yale University by a team led by astronomer Deborah Fisher and installed on the Lowell Discovery Telescope at Lowell Observatory in Flagstaff, Arizona. The spectrometer was able to measure tiny shifts in starlight from Copernicus as Jansen moved between our planet and the star, like when the moon blocks the sun during a solar eclipse. The researchers determined that Jansen orbits along the star's equator, but the Hell planet is not only the planet orbiting Copernicus. 4 other planets on total orbital paths populate the star system. The astronomers believe Jansen's oddball orbit suggests the planet initially began in a cooler and more distant orbit before drifting closer to Copernicus. Then, the gravitational pull from the star's equator changed Jansen's orbit. The journal Nature Astronomy published a study detailing the final findings on Thursday. Astronomers expected this planet formed much further away and then spiraled into its current orbit, said Fisher, senior study author, and Eugene Higgins, professor of astronomy at Yale, in a statement. That journey could have kicked the planet out of the equatorial plane of the star, but this result shows the planet held on tight. Red-hot exoplanet. Despite the fact that Jansen hasn't always been as close to its star, the astronomers concluded the exoplanet was always scorching hot. The planet was likely so hot that nothing we're aware of would be able to survive on the surface, said lead study author Lily Zahau, a research fellow at the Flatiron Institute Center for Computational Astrophysics in New York, in a statement. Once Jansen's moved in closer to Copernicus, the Hell planet became even hotter. Our solar system is flat like a pancake where all of the planets orbit the sun on a flat plane because they all form from the same disk of gas and dust that once swirled around our sun. As astronomers have studied other planetary systems, they have discovered that many of them don't host planets orbiting on one flat plane, which begs the question of just how unique our solar system is in the universe. This kind of data could provide more information about how common Earth-like planets and environments may exist in the universe. We're hoping to find planetary systems similar to ours and to better understand the systems that we do know about, Zhao said. The primary goal of the Express instruments is to spot Earth-like planets. Our precision with Express today is more than 1,000 times better than what we had 25 years ago when I started working as a plane hunter. Fisher said, improving measurement precision was the primary goal of my career because it allows us to detect smaller planets as we search for Earth analogs.